All right, we have laid all the groundwork, so now we are ready to start factoring and solving polynomials. So example 5 says, for the polynomial f of x, we need to list all potential rational zeros, use the graph to eliminate some potential zeros, find all rational zeros, and then factor. Now, I've made a little note here. I got this question from my math lab, so you're going to be asked to do something very similar to this in my math lab. But whether they walk you through this process or not, these are kind of the steps that we are going to be using every single time. You are always going to start with your P over Q. We're going to look at our graph. We're going to find our zeros, and then we will either factor or just list them. So list your potential rational zeros. We need to do our P over Q. Now with this one, my P is 20. My Q is 1. So when my Q is 1, if I have P over 1, that's just the same as P. So all I need to do is list my factors for P. And your multiples for 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Okay, I personally like to list these in order, but you don't have to. So you could do 1 times 20 right there together, 2 times 10 together, and then 4 times 5 together. So this gives me my starting point. And once we get to question or example 7, I believe, this will make a lot more sense why this is such a crucial step. So kind of bear with me here. But on B, now we need to use the graph to eliminate some potential zeros. So I have listed 1, 2, 3, 4, 5, 6, 12 potential rational zeros. What's the maximum number of zeros I'm going to have here is 3 because of that x cubed. So we're going to take this and we're going to eliminate some. And we're going to graph this. So I am putting in x cubed plus 8x squared plus 11x minus 20. I'm going to go zoom 6. No, I'm not. I shouldn't have done that. What I actually need to do is look at these numbers here. What is the potential lowest and biggest zero that I could have? This right here is my potential biggest and smallest zero. So this means I need to have an x min of negative 20 and an x max of 20. So let's try this again. We'll do negative 20 to 20. And now I'll hit graph. I don't really care about my y's. And so what zeros can I safely eliminate? I want you to think about that for a second. Of these 12 potential rational zeros, what numbers can I safely eliminate? Well, since I changed my window to negative 20 to 20, I have negative 20 here, there's nothing there, and I have positive 20 here, there's nothing there. So here, I can eliminate my plus or minus 20. Is there any other numbers I can safely eliminate by looking at this? And about halfway, we have negative 10. Nothing's there. And about halfway here, we have positive 10. I can safely eliminate positive and negative 10 as well. So now let's zoom in. And now my biggest and smallest is this positive and negative 5. So I'm going to go negative 5 to 5 and regraph. And now I can see where my zeros actually are. From my calculator, I can actually see all of my zeros since these are all whole numbers in rational zeros. Here we have negative 5, which was in my pool. of potential zeros. I also have -4, which is also in my pool of potential rational zeros. And I have 1, which is also in my pool of potential rational zeros. And you can use your calculator to use your trace to even check it. If I do -5, we get 0, -4 is 0, and 1 is 0. Now, technically for this one, we can stop right here, but I want you to see where we're going to go from here. Because in the future, all we're going to have is one rational zero. The rest are going to be irrational or complex. So when that happens, let's say that from the calculator, all I could see was this -5. I would take that -5 and I would have to divide it out. So we will use synthetic. I have x cubed, x squared, x, and my constant. Nothing is skipping a place value, so I don't need any zeros here. So we have 1, 8, 11, and -20. Bring this one down and multiply, add till the end. So multiply, add, multiply, add, multiply, add. So if we did not use the check feature on our calculator, by getting that remainder of 0, that is verified. So this was my remainder, so that makes this my constant, my x, and then my x squared. So what I am left with is x squared plus 3x minus 4. So if I factor this, my a times c is -4, my b is 3, what adds up to b, but multiplies to ac, and that is 4 and -1. 4 times -1 is -4. When I add, I get to 3. This one's an easy trinomial, so it factors to just these two numbers. We get x plus 4, x minus 1. When you set this equal to 0, you get -4. When you set this equal to 0, you get 1. So in the future, what's going to have to happen, we're going to list our potential rational zeros. We're going to eliminate some to zoom in a little bit better. We will only be able to see one rational zero. We'll have to divide it out and then solve the whatever quotient, whatever quadratic quotient we have left. So now my factor is going to be, we first divide it out in x minus 5. When that's a factor, that is x plus 5. Then x plus 4. And then x minus 1. Now, we're going to use these steps every time, even if it doesn't walk us through it. If you come to this problem and you can see all of your 3 rational zeros or 4 rational zeros, you don't need to go through this process, but I wanted you to see where we are heading, which is where we're heading right here in example 6. Example 6 says, use the rational zeros theorem along with the graph to find a possible real zero of the polynomial function. Find the remaining irrational zeros. So we're going to have some square roots and factor the polynomial over the real numbers. So here is my f of x. It jumps straight into a possible zero from the graph is. We need to start with that rational zeros theorem. So if I list my p over q, my p is 46 and my q is 1. So because my q is 1, p over 1 is just p. So let's list our factors for p. My factors for p are plus or minus 1, plus or minus 2, plus or minus 23, and plus or minus 46. Okay, so let's graph this. We're going to put this in our y1. And this time my x min and max needs to get changed to right here. We're going to have an x min of negative 46 and an x max of positive 46. So window negative 46 to 46, and I don't care about my y. So hit graph. What can we safely eliminate here? Well, negative and positive 46 is on the edge. Nothing's there, so that's gone. And then halfway would be my negative 23 and my positive 23. And that's gone. So let's zoom in. Now my biggest is plus or minus 2. So negative 2 to 2 and hit graph. It's thinking, okay? And it's crossing what looks to be on the very edge of my graph. Let me just change my window here to maybe a 3. And it is crossing right there at 2. We can do trace 2 to verify that. So a possible 0 from the graph is when x equals 2, which was part of my potential rational zeros. Thus, a factor should be x minus 2. Now, part B specifically says to use long division to find the reduced polynomial and then find the remaining zeros. If I have x minus 2, do I have to use long division? No. And my math lab's not going to know which method you use, and you get the same result whether you use long division or synthetic, so let's just use synthetic. So we'll put the 2 on the outside. I have x cubed, x squared, x, and constant, so I don't need any zeros. We have no placed values. So we have 1, negative 2, negative 23, and 46. Bring down your first, multiply, add till the end. So multiply, add, multiply, add, multiply, add. So if we did not use the trace, we have verified that this is a factor since we have a remainder of 0. Here's my constant, my x, and my x squared. So we have x squared minus 23 as my result, my reduced polynomial. Now, I cannot factor this because this is not a perfect square. If this was minus 16 or minus 25, we could factor that, but I can't factor that with this being a non-perfect square. So I'm going to add in here an equals 0, and now we're going to solve. We have 3 ways to solve quadratic equations. We have factoring, which we just ruled out since that's not a perfect square. We have quadratic formula, and that would work. My a is 1, my c is negative 23. Or we have the square root method. And because I have no b, square root method is the best one here. For square root method, we want to get that x squared by itself. So we'll add our 23 over. And then if I take the square root of both sides, we get x equals, remember, I need 2 solutions from here. So I get my 2 solutions from plus or minus. And 23 is a prime number. If we broke that down, the only way we can is by 1 and 23. So I'll have a pair of anything. So this stays as the square root of 23. So here are my remaining zeros. And now use the real zeros to factor f of x. So we have f of x equals, we found our first solution to be 2. We divided that out. So we have our first factor of x minus 2. And then here are my other two factors. We'll have x plus the square root of 23 and x minus the square root of 23.